Lesson 29, two-column proofs. So first off, look at these algebraic properties. As we bring them up and look at them, they'll make more sense. But just look at what this is saying. If A equals B and C equals D, A plus C equals B plus D. Okay, so that's just saying that you can add something to both sides. Subtraction property. If A equals B and C equals D, then A minus C will equal B minus D. Multiplication. If A equals B, then CA equals CB. So that means you can multiply on both sides. Division property. If A equals B, and as long as C is not 0, you can divide both of them by the same number, and they'll still equal each other. Distributive property is where you take, if something's in parentheses, instead of having A times B plus C, it could be AB plus AC. Reflexive property, this one seems really weird. It just says that A equals A. This would be useful. It seems strange now. It won't come up a whole lot on today's lesson, but that would be useful if, for example, I have like two triangles and I want to prove that they're the same triangle, and all we know is that this side right here is 3, and then maybe this side is 2, and this side is 2, this side is 1, and this side is 1. And so I'm trying to use, actually, you know what, if I wanted to do it right, let's say we know that this angle is 30 and this angle is 30, so we want to use the SAS property, the side angle side property. Well, we know that these sides are equal, and then this side is equal because it's itself both times, so 3 equals 3, right? That's where reflexive property will come up and make a lot of sense right there. So with that one, let me make sure. I want to have this up as I do this right here. Okay, so with that reflexive property, that doesn't make quite as much sense for what we're doing today, but it will come up later when we're actually using geometry, doing shapes. Symmetric property, if A equals B, then B equals A, you can flip it. Transitive property, if A equals B and B equals C, then A has to equal C. Lastly, substitution property is that if A equals B, you can sub A in for B or B in for A. All right, so what we're going to do here is something called deductive reasoning. I'm not trying to get out of my lane here. We're trying to keep it math. But the truth is that a lot of people cannot argue their points. I mean, whether it's anything, any discussion you want to have with somebody, if you find yourself, you know they're wrong, but you're just frustrated because you can't even talk to this person, it's probably because they don't know how to use deductive reasoning or deduction. What deduction does is it starts with you begin with the starting point that we agree on. If we don't agree on it, you need to explain the starting point to the person. And then what you do is you get to a conclusion using deduction by having established assertions that we work with. So what you do, there's a bunch of assertions that are true that we, for the sake of what we're doing today, we're not going to need to explain ourselves every time why we know they're true. Today, these will be our assertions that we say for sure are true. Okay? So if you need to have these proven to you, we can do that. But just know they've been proven time and time again. We know that these things work. Therefore, we can use them to make a different argument. That's the whole point of deduction, is that you're using assertions we've already established to get to a new thing we haven't established yet. Let me give an example that might make some sense to some of you. Some of you are going to be like, what are you talking about here? But like a huge argument in sports, people always argue who's better, LeBron James or Michael Jordan. People would disagree because both are making completely different points and neither is willing to establish their point. So I could say Michael Jordan is better because he's won more championships. Somebody else could say LeBron James is better because he's been to more championships. Okay? LeBron James has been to way more championships than Jordan has, but Jordan right now has still won more than LeBron. So we're both right. I'm right in saying, oh, Jordan's won more. The other, I would be right in saying LeBron James has been to more. The problem is nobody's agreeing. We need to agree if it means more to win championships or means more to be to championships. The problem when you're arguing with somebody, if you don't set up something that they've agreed to make your point, it doesn't work, right? So then the next guy could say, oh, Jordan is better because he scored more points. Well, or we could say he's better because his averages are higher for scoring. We first need to agree that having better scoring averages means you're the better player. We would first need to agree that more championships means you're the better player. You see, you can't just make a point if you don't establish that point. So this section of geometry is the section that if this clicks in your brain using this process of logic, it can apply to a lot of things when you discuss things. We're going to only use stuff we know is true in order to make an argument. So let's look at this. Here's how can we say that 4x plus 9, let's say if 4x plus 9 equals 18 minus 1/2 x, how can we figure out what x equals? Using these already established properties. Here's what it'll look like, okay? So what did they do to get from this line down to that line? In fact, what I will do for this one, I'm gonna do this one. I'll let you see what's going on. From right here, you looking at it, this might be so confusing to you. So let me do something that'll help. Okay. So let's zoom out of this. Look at what I have here. So that's our equation. Forget all this stuff on arguing for a second. What would you do to solve this? Well, you would add plus 1/2 x to each side. So it's gone from there, plus 1/2 x. So now we're at 4 and 1/2 x plus 9 equals 18. Okay, that's the step that we would take. What lets you add something to both sides? That would be the addition property. So look at how they get here, and they say the addition property. See what they're doing here? They're not showing you that what they added to both sides. They're just saying you can get from this line to that line, and how do you do it? By using the addition property. Okay, now we can get from this line to that line, and what are we going to do? So let's just do what we would do if we were solving a problem. What would be the next step? So see right here, here's the actual step that I took that they're not showing you. So let me show you another step that they're not showing you. We would do minus 9, so it's gone from there. Minus 9 gets us at 4 and 1/2 x equals 9. Okay, so they got to 4 and 1/2 x equals 9. What did they do? They subtract 9 from both sides. Look at this right here. You see that? They subtract 9 from both sides. That's what they say, subtraction property. You subtract 9 from here, subtract 9 from there, boom, you get right there. And lastly, they're doing division property. What are they dividing by? So I'll go right here. If you then divide by 4.5 x, divide by 4.5, divide by 4.5. 4.5 divided by 4.5 is x by itself. 9 divided by 4.5 is going to be 2. And there we go. So you see how they do that. They're doing each step, but they're telling you what the rule is, why you're allowed. Because see, you could get from here to here and be like, well, why are you allowed to do that? Because addition property tells me you can add to both sides. So this is how we're going to look at problems for a bit. Instead of actually we're going to do math problems we all should know how to do. But instead of actually writing out all of the work, we're going to explain what properties let us do the problem. So look at this. What we're going to move now is to something called a two-column proof, which is really this, just in a more organized fashion. So what you can do, you can organize the steps and the reasons used to justify the steps in 2 columns with statements on the left. So on the left, you state what the new answer will be after you do each step of math. So we start here, we can get to there, we can get to there. And then on the right, you're going to give the reasons. Today, that's the properties, goes on the right. This is called a 2-column proof. So look at this example. We start off with 3, parentheses, x plus 2 minus 1 equals 5x plus 11. How can we solve this problem and end up proving that x equals negative 3? So look at what you do. You always start off with what they tell you. So they're telling me this right here. So you start off with that and you say, what's my reason for all this random stuff I'm writing? You say given. That's what was given to me to begin with, okay? What's the first step to get from here to here? What are they doing? Can you take a second and look at this? What's happening? This negative 1 is gone, and then suddenly this goes from 11 to 12. What are they doing? They're adding 1 on both sides. Can you see that? Plus 1 right here, and it's gone. Plus 1 right here, and 11 turns into 12. And we're there without the 11. Okay, what's that called when you add to both sides? The addition property. Okay, look at what they do next. They take 3, multiply it by x to make it 3x. They do 3, multiply it by 2 to make it 6. What is that property that lets you multiply both parts of the parenthesis? That's the distributive property. So distributive property lets you do the math to get from here to here. Okay, let's see what happens now. Now suddenly go from this one to the next line. The 3x is gone. So they did minus 3x. And if you do minus 3x right here, what's 5x minus 3x? That'll be 2x. What says you can do minus 3x on both sides? Subtraction property. And boom, we're right here. Okay, now what are they doing? We go from 6 to negative 6, and the 12 is gone. Can you see what happened? You do minus 12, so it's gone, and minus 12 turns 6 into negative 6. Subtraction property. You subtract from both sides. Okay, now the next step, if you take this and divide by 2, x divided by 2 is just x. And negative 6 divided by 2 is negative 3. Division property, you're dividing on both sides. And then lastly, we flip it. We want it to be nice, clean, x equals 3 because that's what we're set out to prove. And so it's the symmetric property that lets you take an answer and flip it. So you see, this is math that I think you could all do. If I just started you with this, said, hey, figure out what the answer is, you can do that. The issue here is not making sure you can get to the answer. The issue here is explaining it, making sure every step makes sense. You see in a lot of arguments, that's the problem. You might think Michael Jordan is better, but you need to be able to explain each step that will get there. Okay? We don't have to explain why distributive property works. We just know it works. But if you're in an argument and your point is, oh, LeBron is better because he has more assists, okay, whatever, you then need to prove that more assists means the person is better. You see what I'm saying? So the problem with a lot of people's argument is not that they're making statements that are false. It's that they're not proving that their statements mean what they want it to mean. So math, it's really easy. You only use statements we've all already agreed on. So that's why if you have a mathematical mind, I don't know, you can normally you can explain stuff a little better in just like normal everyday things, because the way your mind works is you think, I'm only going to take a step if we know for a fact that step works. Okay, so here's what I want you to do. I want you to try to solve this proof, figure out what's taking place at each step. All right? So 1 through 7, you're telling me which property is used at each step. So press pause, give that a try, and then press play. Okay, so I'm going to write this out right here as we go along. It's going to be really easy to run out of space, so I'm going to have to not write too big. So what we have here is we have the proof, and it is, we're given, so we have step 1, we have x minus 3 over 2 equals 6 plus x over 5. Okay, step 1, when you write the stuff they tell you, it's always going to be given. So question number 1, I mean, the answer's already there for you, so that shouldn't be a problem. Again, I don't know if I made it clear, but I want you to try this yourself. Press pause, try it yourself, and then press play after you've gotten to think on it yourself. Okay, look what they do for this. This might be kind of confusing. This might not be the way you would have gone about solving this problem, but they take this and they randomly have a 10 right there. Okay, so look at this first step. There's randomly a 10 on each side. Okay, you see that? What allows you to randomly put a 10 on each side? If you want to take a second, go look at the properties. You can do that. Think about it. What lets you put a 10 on each side? So how do I have just a 10 on each side? That would be multiplication property. All right, so if you have a 10 on each side, why do you get to multiply the left by 10, and why do you get to multiply the right by 10? What allows you to do that? Multiplication. Okay, so we use multiplication property, we put that there. And then how do we suddenly, so on this one, let's look at step 3. So now in step 3, we have 5 times x minus 3 equals 2 times 6 plus x. Okay, so again, look at your properties if you need to. And how can you go from having a 10 here, and now it turns into a 5, this 10 turns into a 2. Think about what would cause that to happen. This is kind of a difficult one. It's kind of it's a little bit different. And if I think out of all of them, this step's probably the hardest. You can probably see me on the computer. I'm pulling up the Springboard version of this. So what allows me to say that instead of 10, I get to put a 5 there. And instead of 10, I get to put a 2 there. Here's what they're doing. This is really 10 over 2. And this is really 10 over 5. That's what's really there, right? You see that? It's a 10 over 2. Because notice right here, the 5 turns into, or the 10 turns into a 5, but the 2 is gone. So they divided that right there. The 10 is over a 5, it turns into a 2. Here's what's so confusing about this. And if this is one that you got wrong, I understand. You would be tempted for number 3 to put the division property because you're saying, oh, we're dividing both sides. I'm dividing this one by 2 and that one by 5. Here's the difference. Division property is when you divide both sides by something that's not actually there. With this, what is 10 over 2? Well, that's 5. We know that. So what we're doing, we're substituting 5 in the place of 10 over 2. And right here, 10 over 5, we know that's 2. So we're substituting 2 in the place of 10 over 5. So it's actually the substitution property. Okay, let's jump up right here real quick. And look right here. What substitution says, if A equals B, then A can be substituted for B. So what that means is anytime if you have like 3 over 1 and you'd rather just write 3, or if it's 3 squared, you'd rather write 9, or if it's a 2 plus 2, you'd rather write 4. Anytime you solve a little piece of it and on the next line you give the answer, you'll put substitution because you're substituting in, instead of 2 plus 2, you're substituting in 4 in its place because they both equal the same thing. That might be confusing, but when somebody says, why do I get to say that this turns into that? We don't need to tell them because 10 divided by 2 turns into 5. That's already known. We're saying, but why is it if 10 over 2 equals 5, how come at any point I can just write 5 there instead? Because substitution property is what says if you know what something equals, you can put it there instead. Okay, this is definitely the most confusing step in this proof. Okay, so now let's look at step 4. Now in step 4, suddenly we have 5x minus 15 equals 12 plus 2x. Okay, so what did we do here? They took the 5 and did it times x, times negative 3. You see that? They did 2 times 6 times x. That's how they got here. What's that called when you take something, distribute it to both parts in the parentheses? Hopefully you got that. That's distributive property. Okay, next step of the proof. Let's see what they're going to do next. Suddenly we have 3x minus 15 equals 12. What did they do the proof? Well, what they did is they did minus 2x right here. So it's gone. And then they did minus 2x right here. So it turns into a 3. So what's it called when you subtract something from both sides? That's called the subtraction property. All right. Number 6. 3x equals 27. What happened there? How did this leave and this got bigger? Well, because we did plus 15 to make it go away and plus 15 to add it over there. That's called the addition property. All right, and then number 7, last but not least, we suddenly have x equals 9. How did we get there? Well, to get there, what we did is we divided by 3. We divided by 3. So that's the division property. All right. So it's given, multiplication, substitution, distributive, subtraction, addition, division. Okay, that's how we do a 2-column proof. That's your first 2-column proof in this class. All right, let's keep moving forward in the lesson. So this is, we have the answer to all of these now. Okay, let's do number 8. What statement tells you that if 4x minus 3 equals 7, then 4x equals 10? What statement says that that works? What math was done here? Take a second, think about it yourself. Mark your answer. So press pause, think about it, mark your answer, then press play. Okay, look what they did. You did plus 3 to make it go away, and then 7 plus 3 makes it to 10. So it's addition property. Okay, below is an incorrect proof. The given statement should not lead to the final answer. 4 of the statements and reasons are correct, but 1 is wrong. Which line of statements and reasons is wrong? So let's look at this and figure out where they went wrong. So we have 3x plus 5 equals negative 6x plus 6, because that's given, that looks fine. Distributive. You distribute 3 to make it 3x, distribute 3 times 5 to make it 15, distributive, that looks good. Okay, now we're going to do addition. So suddenly we have, this is gone, so you must have done plus 6x to make it gone. Plus 6x to this would make it 9x. So this turns into 9x, 15 stays, 6x was eliminated because you had 6x, and the 6 goes. So addition, this looks fine. Okay, next line says subtraction. So 9x stays, the 15 is gone, so you must have done minus 15, so it's gone. And then 6 minus 15 makes it negative 9, so it's all good. Okay, now think about it. What would you do here? You should divide by 9 and divide by 9. But what do they say? They did multiplication. They multiplied by 9, and got negative 81. Should you have multiplied? No, you should have done division, divide by 9, and you would have gotten x equals negative 1. That's what the proof should have been, is x equals negative 1. All right, so which line was the mistake? Line 5. Okay, now let's do this proof. We have 4x plus 9 equals 18, minus 1/2 x, and then we have to prove x equals 2. So let me make some space so we can do this one. All right. So we have 4x plus 9 equals 18 minus 1/2 x. And what's the reason for that? What is step 1? Step 1 is always because you're going to say given. Okay. And we have 4 and 1/2 x plus 9 equals 18. So let me write all these down. So you can press pause, or, well, you try this. Press pause, try it, and then you can press play, and we'll go through the whole thing. 4 and 1/2 x equals 9. 4x equals 2. Okay. So let's try this one here. So let me zoom out. I should do this so you can see. Okay. So how does the first thing always get there? Because it's given. All right. What did we do here? What kind of math happened? Well, it must have gone plus 1/2 x. And if we did it there, we do it over here, plus 1/2 x. So the negative 1/2 is gone, and then plus 1/2 x makes it 4 and 1/2 x. What is it when you add to both sides? That's the addition property. Okay, what's the next step? Well, it must have gone minus 9, so it's gone on the left side, and then 18 minus 9 turns this into 9. What is it called when you subtract from both sides? Well, that would be subtraction. And then lastly, we divide by 4 and 1/2, divide by 4 and 1/2. 9 divided by 4 1/2 equals 2. That was division. Some of you might have noticed that this was just in proof form of the very first example that I used to show you how to use these properties. If you go up here, all that was is just this right here, but in proof form. That's all we just did. Some of you might recognize that and just scrolled up and looked at all the answers. But So fill in each of those lines for here, and then you are done. I know this is a different kind of lesson. It's a longer video than normal. So if you're having a struggle on this, please email me if you need help. Other than that, have a great day, and I will talk to you guys soon.